Lou, Greg, you still there?
Still
yeah,
here.
we're here. I think everyone can hear us now. We should be live.
Cool.
So thank you for joining us. Those of you who've hopped on already, we're going to be starting here on time. And we want to just let you know that we appreciate you taking the time from your busy schedules to be with us today. And while you're waiting, if you have some ideas of a couple of potential questions, please jot them down so at the end we'll have a little bit of a Q&A on that.
And this is our second presentation right now, so still getting some kinks out. If anyone can hear us, just chime in on the little chat below. Say yes or no. I assume if you can hear me, you would just say yes. If you couldn't, you probably wouldn't answer at all. But yeah, so if you could just chime in, help us out. We're going to start off in just a second. It is, according to my phone, 10:01. I haven't seen any responses. Let's see. All right. Well, we opened it up, so I'm assuming everyone can hear me. So let's just kick this off. So I'll start off with a nice little good morning, everybody. My name is Greg Rath from Rath Associates, and thank you for tuning in for our second of our 20-minute webinar series. So the topic of this discussion is breathe easy during the COVID-19 pandemic. So this webinar series, like I mentioned, it's a 20-minute series. It's a little different from what everyone's used to. Right now, everyone's seeing these hour-long webinars. There's probably dozens and dozens of them showing up in everyone's inboxes, and we've all been on webinars. My experience and everyone's experience, I think, is generally an hour is a lot. It's very difficult to really give a lot of focus and attention to an hour-long webinar. We all end up focusing on emails and people barge in. So what we're doing is a bit more of a TED Talks type of concept. We're trying to keep it, we're going to keep it under 20 minutes, not including this little intro, but we're going to keep it under 20 minutes. It's going to be a high-level discussion to really introduce topics and introduce concepts and really show you some problems and the way that the industry is currently solving them. And then towards the end, we're going to introduce a way that a product that we think is probably the best solution for solving it. So after the 20 minutes, we're going to actually break for about 2 minutes to do a $500 fundraise giveaway. So what we're going to do is we're going to post up a little poll of 3 different charities that we would really like to donate to, and we're going to ask that you guys select which one that we send it to. After we're done with that, we're going to come back and we're going to really have about unlimited Q&A. So again, this is high level. Ask whatever questions you want. We'll dive into the details. But a big part of this really is also to make you maybe think about something you weren't thinking before, and then you can actually reach out to us. Phone 631-822-1200 or email us at support@rathassociates.com. And we can get involved with you on a one-on-one or meet with your team and dive in a bit deeper. So without further ado, I'm going to pass this off to Lou Garavito. He's going to continue this. Lou, can you see if you could change the slide? Let me know if that's taken effect.
No, not yet.
All right, just give us 1 second.
Okay, while he's doing that, let me just jump in with the fast pace. Thank you for joining us again in our continuing series of webinars from Rath. With the fast pace that our Times has given us is that we're working, Rath has been focused for several months now, probably about 6 months or a year, looking at Local Law 97 and the upcoming changes with carbon reduction, which is very important. You take that fast forward, you throw in COVID-19, and that really effectively shut down the city. Now, with that said, we have to take a look at, we're offering an option to provide supplemental fresh air to areas in a facility where you might have the most opportunity to have a need. All right, so this is going to give you the opportunity, places to look at. It's going to be classrooms, conference rooms, lunch areas, exam rooms, workout areas. Conference rooms, again, is a key place where you have a congregation of people where importing a lot of the fresh air is going to be vital to that. Very timely, on March 4th, the New York Times put out a report on ventilation systems can spread disease. The article goes back to the culprit back in the 70s, where a circulation ventilation system where a child with a measles went to school, primarily stayed in one class, and Dr. Joseph Allen reported that with 97% of the fellow students who had been vaccinated, 28 of them contracted the disease, and the culprit was the ventilation system. So we're tying in how buildings have a tendency to have a potential risk with regards to that. So a lot of the buildings have been recognized by EPA as being sick buildings. Other places have identified 1 out of 4 have an indoor air quality issue. And the reason for some of this is back in the 70s, when we have the oil embargo, a lot of the requirements would change in an effort to try and save on energy. They changed the requirements going from about 15 cubic feet per minute per person down to 5. And as a result, we have a complexity of the situations where you introduce a reduction of fresh air into the space, and you look at what the impact is, where EPA also identifies that indoor air quality is a problem where it can happen, and generally, this is before COVID, we're looking at a cost annually of $168 billion, and $60 billion of which is considered loss in productivity. When you look further into it, if you Google the cost of COVID so far, it's estimated to be somewhere between $1 to $4.1 trillion. So with that, we have a real expert on this presentation, Klas, who has been a chairman on several of the committees on ASHRAE, and he will take an important part in this.
All right. Thank you, Lou. I appreciate it. I was sitting chairman of Technical Committee 5.5 Air-to-Air Energy Recovery for ASHRAE, and I asked an open forum at a national ASHRAE meeting, what is the impediment to using more air-to-air energy recovery, with 62.1 requiring more ventilation air and 90.1 asking you to use a lot less energy? It really makes sense. And the overwhelming answer was none of the energy recovery equipment is really that reliable or effective, and the second component was cost, which I take to mean what is the payback, and we'll get into that a little bit. I was also chairman of 7.8, owning and operating cost of commercial buildings. I'm in the front of the ASHRAE handbook in 2011 and 2019. And really, you know, Fred Turner, the editor of ASHRAE Journal, he pretty much says, if you're going to have a product in a building these days, it needs to be something that's going to last for 20 years without a lot of work. I've also written a lot of the standards. I was on standards committee for high performance buildings 189.1, and I was also a voting member and contributing author to GPC 32, the Sustainable High Performance Operations and Maintenance component. And I wrote the standard on testing air-to-air energy recovery devices, standard 84. So here I am in 2012. I won the first ever existing building Emmy from Urban Green and USGBC. We took a 658,000 square foot industrial complex in Edison, New Jersey off the grid. And it was a combination of a myriad of different things, but energy recovery was a big part of it. So here, when we take a look at the ventilation rates, this has helped a lot of people I know understand buildings. It's helped me. But if you go back to the late 1800s, the ventilation rates in Chicago were as high as 40 CFM a person. The guy who put this together is actually a past sitting president of ASHRAE International, Fred Klas. And he really, historically, he understands buildings. He's worked easily on thousands of large scale projects. And he put this graph together, and this has been peer reviewed by a lot of people. But the interesting thing is, you see the trend before there was really air conditioning, the ventilation rates were very high in Chicago and New York. 30 CFM a building was a person per each person in the building was standard ventilation rates, which is a lot higher than what we have today. And you see that ASHRAE wasn't ASHRAE, it was ASHVE, American Society of Heating and Ventilation Engineers. And then in the 30s, Dr. Carrier comes along, and I got a chance to see his lab. He actually has a slide rule that was hexagonal. It's for the different refrigerants he was using. Very, very intense guy. But anyway, he invented centrifugal chillers, and the American Society of Heating and Ventilation Engineers now turns into ASHRAE, the American Society of Heating, Refrigeration, and Air Conditioning Engineers. And then with the Carrier weather maker, they start making claims that they can recycle the air and temper it, which is true. But after the oil embargo of the 70s, we go down to 5 CFM. Now, 5 CFM, if you go to the envelope component of the ASHRAE handbook, you can justify that just by leaky building envelopes and doors and windows and the cracks around them. So if you're designing a building to 5 CFM a person in the 80s, chances are you had no outdoor air intake, even if the building's a couple 100,000 square feet. So fast forward, that turns into coining the phrase sick building syndrome. So now what do you do with a building where the chiller and boiler are sized for no outdoor air? And now you do a tenant fit out, and all of a sudden you have to ventilate and move a lot of air, especially if it's a doctor's or a dentist's office, or if it's something high density use like a law office or an accounting office. The answer is you have to do something. So here in our society today, we have other challenges. We have the flu, we have the cold, and now we have really exotic viruses coming from other parts of the world. And we're learning all about how to surgically prepare your hands, clean them with soap for 30 seconds, face masks, and social distancing. So the world's becoming a little bit more complicated while we're supposed to save more energy. So when we look at this, CDC's recommendation is increase ventilation by opening windows or adjusting air conditioning. The problem with that is if the building was built in the 80s, and a lot of the building stock in our area has been built in the 80s, there is no outdoor air. So the only real option you have is opening windows if they even do open. And opening a window really doesn't ventilate the building as well as mechanical ventilation. So they're basically telling you to ventilate the building, but they're really not giving you a solution. So what we want to do today is give you some food for thought and some options for doing this. And the good engineers at Rathy Associates can support your efforts. So what is demand control ventilation? And this was something that I was involved with as liaison to ASHRAE Standard 62.1 back in 2004. And basically the idea here is you do the ventilation you actually need, and this can be done off a CO2 sensor or an occupancy sensor. And we've done this for thousands of locations. It works very, very well. And here we have a quick comparison. This is from the chapter on air-to-air energy recovery. And you have a myriad of different things: fixed plate, membrane, energy wheel, heat pipe. We're going to go over them briefly. Everything has an application. If you look at the heat wheels and energy wheels, they're good for where you only have like a foot in the ductwork to deal with. Very, very compact, basically take no space at all. Heat pipes are the same way. And then you have a runaround coil loop. All these, over the last 30 years, people have been claiming that the efficiencies are generally higher than they are. Pretty typically, they end up being 40 to 55% thermally efficient. So if it's 0 degrees outside, it's going to get you about halfway to where you want to be. And this is one of the big pushbacks that I've seen from consulting engineers and contractors. Managing expectations, yes, it will temper the air, but it's not really going to help you meet ASHRAE standard 55. If you're nailing somebody with 35-degree air on a 0-degree day, nobody's going to be happy. So fixed plate, we'll talk a little bit about that. No moving parts, easily the most reliable option here. And that's one of the things that I've been involved with designing and researching over the last 37 years. So if you take a look at a wheel, it's amazing how well this system works. You are basically using the wheel as a thermal mass. You have a purge section where you actually exhaust the air to clean out the wheel. One big problem with this is very few people make a wheel that'll last much more than 5 years. Very high quality systems can last 10, but a lot of maintenance with them. It's moving parts. And then if you have something like coronavirus, this is 100% cross-contamination. Your exhaust air media turns into your fresh air media. So a lot of systems are like that. Reverse-o-matic and other ones also have that, where they physically reverse the airflow. So your intake is your exhaust is your intake. But from a thermal sense, this can be over 50% thermally efficient if it's sized aggressively. Then we have the runaround coil loop. This is the very definition of separating intake and exhaust air streams. It's pumped so that it's basically 2 car radiators. So you're recovering thermal energy on one side, either heating or air conditioning, and then rejecting it on your supply air and pre-tempering there. Lately, they have been able to enhance it with evaporative cooling and get it to the point where it is over 50%. But this is generally something that's going to range in the 40 to 55% thermal efficiency. Okay, then. And here we have a heat pipe assembly. And here, it's actually a lot of times R22. So the warm side will boil, the cold side will actually boil. It goes through, it's very quick. It will transfer the heat in seconds. It does have a potential for fouling. A lot of times it's aluminum fins, copper fins, stainless steel, so it's going to have a fouling factor that's actually pretty high. But very stationary, no moving parts except for the refrigerant, and long lasting. Generally expensive, but neat stuff that works. So ventilation rate procedure, quickly, we're just looking at how much air you need to stay awake. So the people building the Empire State Building were up on girders, plenty of air, they're pretty active. And then the executives in the building 100 years later are falling asleep. So one of the things that we want to do is we want to provide fresh air where it's needed. So here we use the ventilation rate procedure, and this has pretty much been adopted all throughout the lower 48 in Canada. To 62.1, the commercial 2019, and we're looking at the breathing zone ventilation rate in CFM, and it's basically a mixture of the CFM rate per location, per application, per person. So we multiply the outdoor air CFM rate, or liters per second, times the number of people, plus the airflow required per unit area and the square feet of the area. And what this does is it addresses the building like an AT&T switch gear facility where it's 100,000 square feet with only 2 people. You know, 20 CFM wouldn't adequately ventilate that. So after you get done with this, that would end up being 10,000 CFM. So here for our application, we have a office example. And if you look at table 6.1 in 62.1 2019, you find that it's 5 CFM a person. Liters per second is not exactly half, but it's pretty close. So for the sake of keeping things reasonable, we just cut the number in half. And then liters per second is half, but you move it over a decimal point. But the point here is you have 12 people, 1,500 square feet. And when you do the math, 5 times 12 is 60, 0.06 times 1,500 is 90. 150 CFM will adequately ventilate this space. So here we have something we mocked up for a medical examination facility, and the ductwork here was supply ductwork, and what we're now using for the supply was actually the exhaust. So we're repurposing the ductwork to make the examination rooms very negative. We're having every 2.5 minutes, we're having a full air exchange for each exam room. So we are moving at least 300 CFM through each exam room. It's only 90 square feet. So if you think about what that means, every minute, 3 feet from the floor of air volume is moved out. So if it's 9-foot high ceilings, in 3 minutes, you clear out the entire room once. And what they're finding is that this is a big problem for nurses and doctors. If it's just recirculating the air and you got one sick person, the entire area is completely polluted very quickly. With this, we don't have any return air coming from the exam rooms. It's just exhaust. So now we change it from a typical recirculating system with maybe 10, 20% outdoor air to 100% outdoor air. And the exhaust is more negative than other parts of the building. So you're actually cooling and heating these exam rooms with the HVAC system in other parts of the building. And in this case, the energy recovery device used is between 80 to 95% thermally efficient, so that it will do the lion's share of tempering just off the air that you're pulling from other parts of the building. So this is turning out to be a pretty active thing we're doing. So here we do a school example. I've done thousands of classrooms. This is real generic, 1,000 CFM and 1,000 square feet, and it ends up being anywhere from 250 to 450 CFM per classroom. So here, if we go to the next slide. Okay, so the typical unit ventilator blows air into the classroom. And what it does is it's doing dilution ventilation. It's just putting in air and pulling air out. And it's really not getting across the classroom. So to solve this, a lot of schools in our area put an exhaust fan on the interior wall, pull air through the classroom to try to get rid of the stratification. But the main effect is this can move as much as 1,000 CFM of outdoor air in. And if the thermostat on this wall is happy at 70 degrees, when it's 20 degrees outside, you're hitting these students with 20-degree air for a couple minutes until that cooler air drifts across and hits the thermostat. There is no way to fix this. This is just a very uncomfortable system. So what we did in a case like this was we actually sealed up the unit ventilator, and we would have energy recovery bring air in and distribute it and do displacement ventilation and just supply air on one side of the classroom and go to the other. And we got an EPA Energy Star success story write-up on this. But for a school district, it dropped the utility costs 32%, or over $500,000 per year. So here, this is an example of demand control ventilation. CO2 sensor comes on when the students come in, they're breathing, the parts per million CO go over 700 parts per million. ASHRAE 740 over ambient is good, or about 1,200 parts per million. With this system, we can keep a fully loaded classroom of 40 kids at about 800 parts per million. But the neat thing is it solves the problem with laden loads because this only runs when the people are in the classroom. So in 164 hours a week, this thing might only run for 30 hours, which means that your laden load that you're putting the building, the books, everything through decreases by 80%. And this is just simply a retrofit. We've done 100-year-old schools, and it's just putting in an energy recovery ventilator, and you solve a lot of problems. So now we're going to look at a manufacturing example. This is typically water lubricated and cooled CRC computer cutting. And we see here that the floor ventilation area is a lot higher. School was like 0.12 or 0.06, depending on the location. This is 0.18. So here you're getting a lot more ventilation from the floor area. We've got 10 CFM a person, but we only have 20 machinists. This is real typical. So here, what we would do for something like this, pretty typically, we just have a pad-mounted 3,000 CFM unit, and we'd have 3,000 CFM fans, FKD 16s, and we would just push air in, pull air out, and recover the thermal energy. And what this would do is drop the moisture level of the machine shop. I mean, think about it. It's metal parts, and you get high moisture, you're going to get corrosion before you even ship it. So this solves air quality, and it's also good for the process. So now, why are some heat exchangers better than others? The ASHRAE chapter, Air-to-Air Energy Recovery, I was actually the author of it at the time in 2006. We came to a consensus that direct counterflow heat exchangers can approach 100% sensible effectiveness. It's just the nature of direct counterflow. If you look at a cube or if you look at crossflow, 50% is really what they're doing. So the question is, what do you want to do with this? Well, if you had two of these, and a couple companies do that, they'll take 2 or even 3 cubes. So you get 50% of 50%. Two of them now start approaching 70%, actual 70%. If you do 3, you can get up closer to 80%. If you do 4, you can get up over 80. And if you do 5, you can have up to 95% thermal efficiency, as tested by Edison Testing Laboratories and Exova in Mississauga in Canada. Now, when you do this, if you were to make 5 cubes, the thing would be ridiculously expensive, probably 5 times the cost of anything out there. But if you take the cores and you figure out how to make them all at once, now you get 5 ERVs in tandem and you get that 90% efficiency, but they're all in line. The other thing that buys you is very, very low static pressure. So we're actually able to do 95% thermal energy recovery while we're using 1/10 of the fan static. So if we look at this, yeah, sure. Yep.
Hey, sorry to interrupt. It's Greg. Just in the interest of the 20-minute promise, just want to see if we can maybe start tying things off a little bit so we can get to the Q&A.
All right, that sounds good. So here we are. Effectiveness is nice, but lower fan power is even better. You have very low fan power, 1/10 of what's typical. You can have EERs that are over 120 as tested by ETL. And it has a nice payback. And here we see a truck shop in Wyoming, and they're have diesel exhaust, high CO levels, supplying fresh air on one side, pulling to the other, and even in minus 20-degree weather in Wyoming, this works. This is what it looks like from the outside. And see, Greg, there you are. That was now it's time for questions.
That was perfect. All right. So thank you very much, Klas. What we're gonna do is, let's see. You know what? Let me see with this. So we're gonna put up. Okay, guys. So we're gonna actually put up the poll. So right now we're asking everyone to jump in. We're taking, like I said, the 2-minute break, and we're gonna ask everyone to jump in and weigh in on who they would like to see the $500 charity donation going to. So, like I said, Wrath Associates really just wants to, play a role and do our part during this crazy pandemic. A lot of people are being affected in a lot of terrible ways, and we just want to do everything that we can, or anything that we can, to play a role. So, during this presentation and future presentations, we're going to continue doing this, weekly, hopefully. And it's going to be $500 going directly to that charity. And like I said, we just want you guys to have a say in it. So we appreciate we're getting a lot of feedback. It's pretty cool. I'm watching this in real time. It's almost even. So if anyone hasn't voted yet, if they have their heart set on something, get it in. This is pretty impressive. We'll keep this going for another maybe 15, 20 seconds. We'll just see how many people are voted. About 60% of you have. And anyone who has voted, coming up right after this, we're going to jump into the Q&A portion. So please plug your questions in. We're going to address as many of them as we can. And anything, if any of you want to touch base with us directly, you can reach out to us at support@wrathassociates.com. That's support@RATHEASSOC.com. And we can do anything, a bit more detailed overview. We can do engineer PDH level courses where there's actually credits available. But in the meantime, let's see, we got about 83% of you had voted. I'm going to close out the poll. And now I'm going to share. Like I said, everyone, this was a real tight poll. You guys really had your pretty split decision there. Yeah, so the Ronald McDonald House, so we're excited. Wrath Associates has donated to the Ronald McDonald House before. We actually provided a lot of equipment for a snow melting project over there. We did obviously the snow melt, we had the tubing, a lot of the equipment there. So, yeah, that's very exciting. We're very happy to donate that, so we're going to get that out. We're going to get that out immediately. So now on to the Q&A portion. So bear with me. I'm going to have Lou jump in. Lou and I are actually going to moderate this, and we're going to send the questions to Klaus. Lou, are you there still?
I'm here.
Great. So I don't know if you've had a chance to look at.
I do have an immediate question with regards to looking at the overall energy and how does this product help in RAT's efforts with Local Law 97?
Well, one of the biggest wastes of energy is just exhausting already air-conditioned or heated air. If you can recover anywhere from 70 to 95% of that thermal energy, it's going to drop your utility bill. I mean, we've seen for a school district as much as 32%. So it's dramatic. I mean, you got a $2 million utility bill, it's going to be like $600,000 from what we've seen.
Greg?
All right, great. Lou, if you could just maybe keep asking questions. I'm having a little technical difficulties on my side. So you could just kind of.
No worries. I have one here. Okay, so with regards, a quick question was, are we generally selling, is RAP selling? The answer is yes, so the answer is a good one. Another question came in is general office space. I think, go ahead, Klas. How do you handle general office space?
Well, really two different ways. I mean, if it's very typically you pull air through the building, you pull it off the roof, and then you bring it back up and exhaust it. So there you can do a larger modular thing, 20,000 CFM or something like that. The units come in modules that stack in 4 hours. You can put together something you can bring up through an elevator or through the core of the building. And then sometimes you have localized issues like meeting rooms or high density, or we did a calling center for MB&A in the core of a building, and there was no way to really do that from, the standard approach from a mechanical room. So we just put 2,000 CFM units up in the ceiling, and we were able to just pull the air in and out at that location and bring in, a couple thousand CFM of air. And it was
And
a
back
call
to,
center, a couple hundred, so it worked pretty well.
okay, and back to that same general office space, the requirements now is what, 20 CFM?
It's a mixture of 5 to 10 CFM a person, and then anywhere from 0.06 to 0.12 a square foot. And if it's high intensity or workout or something like that, an exercise room will be higher. But it ranges. You do the minimum ASHRAE schedule. It comes out typically like around 14 CFM. But I always like to have a little bit more. I always like to have a little wiggle room. So if I use the benchmark at 20 CFM a person, it usually gives me about 30% wiggle room. So, when it gets really cold, you can slow down the energy recovery and you can get back to room temperature within 5-10 degrees where you started. You meet ASHRAE standard 55 and you save a lot of energy.
Thank you, Klaus. Another question came in regarding the competitive units that are out there. What separates this from others as far as the total installed cost? Because a little side question was as far as preheating or pre-cooling other units.
Well, it turns out that when you do the value engineering on a DOAS system dedicated outdoor air, the energy recovery is usually a very small part of it. The bigger part is if it's only 50% efficient, you need inline heating and cooling, which blows up the cost of the project. The BPE products are basically right in line with the major players in the energy recovery market. There's not a big cost difference, but it does take a lot less power to operate and it's more efficient. So the real cost is you don't have to put in supplemental inline heating and cooling in a lot of places. So.
Thank you, Klaus. That was good. On another question is how, if you're looking at like a lobby mentioned previously in the presentation,
Sure.
how quickly can these get installed?
Well, we have a lot of them now that are going in kind of under like an emergency type thing. So we got stuff in stock, but on any given day, they're flying out the door. People realize now all of a sudden that if you recirculate the air and you got one person with a coronavirus, theoretically, you recirculate it long enough, everyone's going to have it. So it's
okay. On the delivery,
yep.
On the supply side, that's good. But on the installation side, how quickly can they get it in?
We're seeing they're getting them in 1 to 2 weeks. Like even in hospital applications, they're pretty fast.
Okay, and I think you mentioned once that you can, two guys can install a 200 unit in 4 hours.
Yes, that's pretty typical.
Hey guys, okay, I got a question here. I'm kind of back online. Sure. So here's a great question. What is a recommended space? Actually, what is it? As a general rule of thumb, what is the amount of CFM per person in general office space?
I use the ballpark number of 20 CFM a person. When you use the schedule generating from table 6.1, the prescriptive model, it generally ends up being anywhere from 12 to 15 CFM a person. But you don't want to do just minimal ventilation rates, especially today with some of the stuff going on. So if you use 20, I just find that to be a good thing. And then when I'm submitting or doing the plans, then I drill down into the schedule and figure out exactly what the number is. And then I exceed it. I generally like to be anywhere from 30 to 40% over minimal rates. So I got the capacity to do that if I need to.
Klaus, I have another question here.
Sure.
How have you worked in tropical locations with high humidity?
We've done stuff for the pharmaceuticals down in Puerto Rico, and in Central America. And this is real pharmaceuticals like Bard, AstraZeneca, not the bad pharmaceuticals, but there typically we'll do a runaround loop where we will dehumidify and cool the air coming in with air that we're reheating. And we use the energy recovery device as a runaround loop. And we'll do 10 tons of cooling for about maybe 3 tons of chilled water load. And if it's kind of neat. You take the unit up on end, you drive the warm, humid air down through the microtubes, and we will remove as much as we'll go from something that can be up to 80% relative humidity, and we'll drop it 20, 30% on a single pass.
So I got another question here.
Sure.
I guess similar. How does the humidity mitigation in warm weather climates work? And how is it, I guess, compared to the wheel? That's, the common wheel.
The wheels can be up to 70% laden, but they use lithium chlorides. They use lithium salts. Bob Besant is an ASHRAE fellow and researcher at Saskatchewan University, and he's done an awful lot of work with the wheels. And basically what they come up with is you lose about 30% of laden capability every year for the first 3 years. And then your ERV wheel turns into an HRV wheel. So it loses a lot of its laden capability. The BPE units have a patented process where at the end of the fresh air intake, like if you start at air intake at 95 degrees Fahrenheit, 78 wet bulb, our solve on a single pass will be to take that 95 air down to 74.1 degrees. You're actually below your wet bulb. You get condensation, but at the end of flow path, we have a process where we can vacuum out the vapor, the heavier, denser, and even the water droplets. We bring it over to exhaust airstream. And when we do that, we get up to 34% laden. But the important distinction is that that's a mechanical process. So that could last for 20 years. It's not going to have a tendency to degrade. So it's very stable technology, no moving parts. And we can be 81% sensible while we're 34% laden. And that's, Greg and Lou, you have that in a double witnessed ETL test. So, but yeah, it's pretty neat technology. Yep.
Another question, have you worked with any casino applications laden with smoky environments?
Yes, we have. We don't have a cross-contamination problem. We were able to do cigar shops. We did the Englewood cigar shop where, they'll have 20 guys in a 600 square foot room watching Super Bowl. And there we'll exchange the air literally every minute. We'll have a 2000 CFM unit on a 600 square foot space. And then we'll balance it. We'll keep it negative so you're pulling the smoke in and out of the space so you're not getting the next door neighbors. And well, they can actually ventilate it without, in January if it's cold. We'll again do that trick where we'll bring the air in very close to room temperature, and it's actually very pleasant. And it's been working for years, so it is something that works over a period of time. And they've actually washed out the core. The nicotine builds up on the exhaust side. They'll take a hose and wash it out, and then they're up and running again. So, but that's a neat place to visit too.
Yes.
Klas, I got another question. It actually was not submitted, but I rushed you through a slide that I thought was very powerful.
Right.
You showed, you have, I guess, testing done that shows that you're, upwards of 90 to 95% thermally effective. You said 34% latent. But I think the powerful thing was that you show that the amount of energy required to operate the fans for your system is much less than any of the competition. So how does that occur?
Well, we basically because it's a long, direct, straight counterflow unit, we have very little friction, static losses in the system. So when other systems are working at 3 to 4 inches of water column, we're really running at something on the order of ½ an inch. The larger is maybe up to an inch. So because of the configuration and the fact that it's a very long direct counterflow heat exchanger, we have much less pressure losses. Fan laws, you cut the pressure losses in half, you'll find that you use a lot less energy. So one of the things is being a certified energy manager. One question is, does the thing work? Does it recover energy, which is this first column, effectiveness? But the secret sauce really is that the competitors use a lot of energy, where the status quo in the industry uses a lot of energy. We use very little. And when you combine those two, our EERs have been clocked at 126 for the small 200i series. Larger units, it's up over 80. So something that's 4 times as efficient as geothermal, intuitively, it's going to save a lot of energy. And that's why we get the $600,000 savings on a $2 million utility bill. So.
Good answer, thank you. And also, is there a quick response to someone asking, is there a big difference, or what's the big difference between an HRV and an ERV?
An HRV is sensible only. There's no moisture transfer. An ERV, you do have moisture transfer. And there's a couple different ways to do it. Thermal siphons, you can do it with hygroscopic chemicals, or you can just do it mechanically like we do.
And what's been like your shortest payback?
8 months. We did a data center up in Boston. National Grid funded it, and that had less than a year payback. The industrials will have a very quick payback. We did Chanel, the perfume company. They were worried about lower explosive limit when they're bottling a couple thousand bottles of Chanel No. 5. It's 90% alcohol. They would actually get to close to, they'd have a dosimeter on the wall, and they would start approaching the point where they could actually blow the building up. So then they would have pull everyone out and ventilate the space and start again. So when we did that, that had a very nice payback. It was under a year also. Typical residential is more like 3 years. Commercial buildings is something in between. It depends on the application. And of course, your cost of electricity and utilities.
Klas, we got another question here. This actually, I think, kind of applies really to the whole point of the conversation that we were having. So maybe you could just sum up the conversation we've had. What features can the HVAC system add against the COVID-19 spread to spaces?
It will allow you to go into a place where the heating and cooling load capabilities are marginal and exhaust stale air with potentially some bad stuff in it and bring in fresh air, and take a building that basically has no ventilation and turn it into something where it has great indoor air quality and you don't have sick building syndrome. It is something you can go into probably 80% of the buildings and solve the ventilation issues.
Got another one here, Klaus. When you're
Sure.
looking, we had a discussion prior, but another question came in about laboratories and VRFs. Would you have similar application of the product in the building that uses VRFs? And what about laboratories?
Yeah, we do a lot of stuff with variable refrigeration volume and laboratories, but there we leave the fume hoods alone, let them short circuit, and then we do energy recovery on the balance of the building, the offices, the meeting rooms, the reception and hallways. Oddly enough, a lot of chemical facilities are underventilated in the non-working parts of the laboratory, in other words, the offices and the admin. And for variable refrigeration volume, we get close enough to meeting ASHRAE standard 55 without really adding a lot to the load. So we can be standalone, or we can go in through the cassettes on a VRF system or VRV, depending on whose equipment it is.
All right, Klaus, got
Great.
another one here. Before I get to it, I just want a reminder, because we still have a lot of people on the chat, so a lot of people are listening and throwing questions at us. So we really appreciate it. So anyone who's not, or any other questions you guys have, please continue to send in the questions. There's a little question button should be on your webinar dashboard. So keep sending them in. If you have something that you want to address to us directly, again, the email is support@rathassoc.com. That's support@rathassoc.com. And we'll reach out to you and address any of your questions that you have. So let me get to the next one here. I don't personally necessarily understand it, Klaus. Maybe you can make sense of it and maybe give an answer one way or the other.
All right, give it a shot.
What is the recommended spacing if using an ERV between the intake and exhaust? Thinking louvers on side of your building.
Yeah, that's an easy one. That's code required. It's at least 10 feet, and it can be up to 20 feet. If it's medical, they want to see 20 feet. If it's a standard commercial building, 10 feet. But that's very code specific. You have to drill down specifically on the location. But generally, we do stuff all over North America. 20 feet is better. 10 feet is generally okay if it's not medical.
Another good question came in. Hospitality hotel chains. Have we worked with any directly or have any success with one in particular?
We worked with a wide variety of hotels. I think it's a good idea, especially for the athletic areas and the pool areas. So.
I've got another great question here. Where do I buy these? So that's a wonderful question.
Rathi Associates.
So, exactly. So Rath Associates we're representing this line that Klas has. It's the product is called the manufacturer that Klas represents is BPE, Building Performance Equipment, and Rath Associates, we're the local representation for this in our territory. So as everyone or most people should be aware, Rath Associates sells through wholesale distribution. So I would recommend that if you're someone interested in purchasing it, reach out to your local wholesaler and tell them that this is the kind of product that you want, but also reach out to us. We can direct you, or maybe not direct you, but we can at least work with you in selecting and working with a local wholesaler of yours that you want to purchase this through, and kind of coordinate that whole process. So anything that you need from design to technical support, we can really help you along with your project and helping you get this thing in your hands. And Klas, maybe you could also point out the range, the CFM range capacities that we can really handle. I had a conversation once with someone, and their first thought was that this was, this isn't for me. This is so and so. This is the capacity of this is too small or too big. So what is the range that you can cover?
Well, we do a lot of stuff in the smaller ranges. We go from 50 CFM up to just a couple thousand. And then we have larger unitary systems that will go up to 20,000 CFM. Now, we did look at a park for Schlitterbahn, an indoor water park in Kansas, where it would be, -10 outside, and then they want to be a couple acres under a double-walled tent. And there we were looking to exhaust about 500,000 CFM. And it kind of works that it's not going to be in any one location, it's going to be distributed. But they're actually worried about structural issues with excessive water on the exterior skin of their structure. So at one point, it's water, it's a water park, it's a flowing stream. You have to remove tremendous amounts of moisture, but then you got to bring in makeup air. So there, we can go up to 500,000 square CFM.
Another good question. If their customers or their clients are a one-family client, one-family house, yes, where would you typically install this?
Either the attic or the basement. They're long. They're 5 feet long, so we'd lay them across the collar ties, or we put them along the wall or the ceiling of the basement. And then we typically would pull air from the bathrooms, or if we're in the basement, in our area, we have issues with radon, soil gases. So in the basement, in my house, I have up to 3.8 picocuries if I'm not running the ERV. I'll pull 150, 200 CFM of air out of the basement, and then I'll bring in a little bit more than that on the first floor. I just tie into the return on the forced air system. So it's really less than 10 feet of ductwork. And right now, my level of radon gas in the house is under half a picocurie. So in this area, you really do want to do that. You really do want to ventilate the basement, but might want to do the upstairs too, and you just put one in an attic. Typically, in a large house, it's not uncommon to see 3 or 4 units if it's 15,000 square foot house.
And certifications, anything with like Energy Star?
We did get an Energy Star success story, and we have been certified by different programs. We had our units tested through HVI, CSA Canadian standards, and we've had a lot of testing with ETL, Edison Testing Laboratories. And Rathi Associates have those so that, you can do the reality check and see what the independent testing actually provides.
Hey, Klas, got another great question back to the residential, and then I'm going to also kind of hit you with a second question. The second question is your capability of connecting with BMS systems. But the first one I want to ask you is, in that residential application, where would you exhaust from and where would you supply to? So maybe, I'm not sure if this person's specifically thinking of, maybe a 2,000 square foot house or a 15,000 square foot house, but maybe you could address both of them.
Well, typically what you want to do is you want to pull the most polluted air, the air in the bathrooms and the basement, out of the house. If it's a 2,000 square foot house, I would probably, if you're going to do one unit, I would really hit the basement, exhaust that, and then supply to a first floor hallway. If some houses don't have forced air in our area, you provide the air on the first floor, pressurize the first floor, and keep the basement negative. If it's larger, more complex, typically on the first and second floor, I would exhaust the bathrooms, and then I would supply to a common hallway or the return on a forced air system. And that's kind of every house. I mean, we really don't do anything a lot different than that.
Great. And then on the flip, the BMS.
Oh, the BMS, we can use ECM fans with a 0 to 10 millivolt input or 4 to 20 milliamps. And basically the BMS puts in an analog output into the ECM motor or fan. And then you can basically control it any way you want. And on larger applications where we have a couple hundred ERVs in like a magnet high school, they've actually done that and tied in every classroom from their BMS system. So they can actually schedule ventilation. They can jog it if you're over Christmas, the air doesn't get stale. And then they can also schedule it, control it, and they can also monitor the CO2 levels remotely. So if they notice the numbers going up, that's time to go change a filter or go look at something. But yeah, it's a lot of capability, a lot of flexibility.
Hey, Klas, to that point with, you said changing filters, what else might need to be, replaced or maybe regular maintenance?
That's pretty much it. You change the filters. The motors are self-lubricated. We typically use best-in-class motors that are 20-year lifespan motors. Prototype number 1 now is 20 years, and one of the fans is starting to make a little bit of noise. That's going to get replaced. But typically, there's very little maintenance, just the filters.
So, Klas, you stimulated some question here. With regards to, you mentioned in your house, you took your radon levels, and we are in a high radon area. And
yep.
with regards to installing it in the basement or near a mechanical equipment room where your boiler is,
Sure.
could you actually see this as being also a safety product if you have carbon monoxide issues because you're pulling that air out?
It can, but you know, if the radon levels are very high or your CO levels are very high, that's a pretty dangerous situation. You need to remediate that either with sub-slab vacuum, and of course, if your HVAC is throwing off CO, this would give you more wiggle room on that. But you know, safety first. If it's backdrafting or doing something really bad, uh, it's time to go buy some.
Understood.
Yep,
But
yep.
if you had a slow leak in the vent or something, that would this would take care of that. You still have to have your carbon monoxide detector, but this is something that is going to be a little bit of an additional safety.
Yeah, sure. If you're exhausting stale air and bringing in fresh air, yeah, it's going to help. Absolutely.
Greg, I have nothing else on my side.
Yeah, well, you know what? I think I see one final question here, but again, guys, you know, this is unlimited Q&A, so you know, we'll stay on here, you know, probably as long as necessary, as long as the questions keep flowing in. But if anyone wants to really, you know, hit us with unlimited Q&A, you might as well just reach out to us, and we can contact you on a one-on-one basis. So. Like I said, oh, you know what? Two questions. Someone snuck a second one in there.
Oh, okay,
So
but Greg, I do have to get going to the next meeting. I'll do
okay.
2 questions. Okay, let's go for it.
Final
Go for it.
2. We won't handcuff you. So the
There you go.
the first one is what MERV rating on the filters do you recommend in non-hospital environments?
You know, I think MERV 8 is fine. When you look at OSHA requirements for teaching staff in schools, it's MERV 8. But we do have an option for MERV 13 if somebody wants to do that. My wife has allergies, and I just noticed everything works better with MERV 13 with her allergies. So, you know, mom ain't happy, nobody's happy. So might be a driver, you know, if one person's got allergies, but.
All right. And actually, the other question here is really just, is there an engineering firm that specializes in this that would design a system for our customers? So maybe I'll just address that real quick. So, you know, Rath Associates will work with any engineering firm you'd like to work with to help design this. You could reach out to us direct, and, you know, we can definitely point you in some directions of some firms that we've had a lot of great relationships with over the years. So yeah, I'd say in general, maybe reach out to, like I said, either a firm that you've had good relationships with in the past, or just reach out to us directly, and we can assist with any kind of design. So there's a couple other little questions on here that we'll address individually. We'll reach out to you guys. So I think that's basically it. I really want to thank everyone. Klas, I think we really want to thank you. You did a wonderful job. You gave a lot of great information. And the product is obviously a very exciting product. I think it's very fitting for the environment that we're dealing with right now with this COVID-19 thing that's going on. And then to Lou's point, there's the sick building syndrome thing as well. So, you know, even once this COVID-19 thing becomes a thing in the past, hopefully sooner rather than later, you know, sick building syndrome is still a concern that really should be on everyone's mind. And then there's also Local Law 97. Local Law 97 is enforcing low utility bills. It's enforcing low carbon emissions. And if you're constantly bringing in unconditioned air and exhausting conditioned air, you're wasting energy. And not only is that going to waste your utility bills, and it's going to be, you know, anti-green, but if you're a building owner or, you know, an engineer, you're costing that person money now, because they now have to pay potential fines because of their high carbon emissions. So it's kind of like they're getting double taxed, high utilities and the that tax, the carbon tax. So I guess that's my final thoughts on this. I don't know, Klas, do you have anything left you want to say?
No, I think it was a great conversation, and That is the way things are going. You're going to get $1 million tax on the large buildings unless you use less energy. And you know, it's done. It's going that way. So yeah, all good points. Yep.
Great. Thanks a lot. All right, guys. Thank you
again.
again. Reach out to us, support@rathasos.com. And tune in next week. We're going to have another 20-minute webinar, and we should be sending out a flyer very shortly on that. So thanks again, and have a wonderful day, and stay safe and healthy.